first in a series of videos that illustrate the common conventions used in the field of engineering drawing. The videos form part of the engineering drawing course at the Faculty of Aerospace Engineering at the Delft University of Technology. Any engineer in any field of engineering will be confronted with the need to make or read technical representations of designs, equipment, and other objects. In the past, these drawings were made by hand. Nowadays, computer software is used to generate drawings or to derive 2D drawings from a 3D model. Even though a lot of the standards and conventions used in engineering drawing are automatically respected when making computer-generated drawings, it is very important to know the rules of the game when you want to be considered a skillful engineer. Legacy data is very often only available in the shape of hard copy printed drawings, and a lack of knowledge of standards and conventions for these type of drawings can lead to the creation of drawings containing mistakes, which can lead to failure. The Common Conventions for Technical Drawings video series provides you with information on how to read and interpret technical drawings, and forms a solid base for the use and interpretation of the conventions when making computer-generated drawings later on during this course, and for your further professional career. Note, the topics in this series comply with the topics treated in the Common Conventions for Technical Drawings handout. The information captured in an engineering drawing is not meant to appeal to the senses in the sense of the aesthetics of a painting or sculpture. It is meant to document an object or assembly in such a uniform way that a single interpretation of the described geometry is possible. To facilitate this, rules for line types, projections, layout of drawings and other conventions have been internationally agreed upon. Drawing can be seen as the engineer's visual language, and, similarly to a spoken language, it has grammar and rules to be obeyed to prevent miscommunication. In this video, we start with the alphabet of engineering drawing, the line types. Visible outlines and edges are drawn using a thick, continuous line type. Edges are sharp transitions in the geometry, such as corners, cuts, or holes. Smooth surfaces, such as a sphere or a cylinder's round face, do not contain edges, but their outlines can be projected. Centers of cylindrical or spherical geometry are indicated in engineering drawings with a thin chain line. Always draw center lines when you draw an arc, circle, or any side face of a cylindrical object. A cylinder's side face is shown as a rectangle. If no center line is drawn, the view can be misinterpreted as the representation of a block. But if the center line is shown, it is clear for any engineer that a cylindrical item is shown. Pitch circles are drawn in the case of a circular hole pattern. All the hole's centers are present at the pitch circle, so using a single dimension, the distance of all the hole centers to the pattern center is given. Pitch circles are drawn using a thin chain line. Pitch lines can be drawn to indicate that two centers are aligned. Pitch lines are also drawn using the thin chain line. The thin chain line is also used to indicate symmetry in an object. This reduces the need for dimensions, since a dimension on one side of a symmetry line is also present at the other side. Thin dashed lines can be used to indicate hidden geometry, such as voids, wall thickness, or holes. If an engineer decides to use hidden lines in a projection view, all the available hidden edges and outlines in the object should be shown. In some cases, this will lead to reduction of information when too many edges overlap or intersect. In this case, creating partial or full sections is preferred. Zigzag lines or thin irregular lines are used to limit partial section views. A thin irregular line was used when engineering drawing was done by hand, but computers cannot easily generate such lines. Thus, the zigzag line was introduced to meet this problem. Note, both line types are used for the same purpose. All items in engineering drawings beside visible outlines and contours are drawn with thin lines. A thin continuous line is used to draw dimensions. A dimension is composed out of a dimension line with two arrows accompanied by projection lines drawn perpendicular to the dimension line and a numeral. Dimension lines and projection lines are drawn using the thin continuous line type. Leaders are arrows used to indicate an object of interest. The leader can be used with a letter, a symbol, or a remark. Leaders are drawn using a thin continuous line type. Section views will be treated in one of the next videos in this series. Section views contain a hatch pattern, which is also drawn using the thin continuous line type. In CATIA, the 3D modelling application with which you will work during the last part of this course, a thin continuous line is used to indicate transitions of curved surfaces, such as a rounded edge and a planar face. These lines may not be used for dimensioning. Settings can be changed in CATIA, resulting in hiding these lines when the engineer decides this will provide more clarity compared to the setting where the lines are shown. A special line type is used to indicate a section view's cutting plane. The line is a thin chain with thickened ends, with two arrows perpendicular to the ends. The arrows are drawn using the thin continuous line type and are accompanied by two letters. A thin chain double dash line type is used to indicate extreme positions of movable parts. Only the outer contour of the movable part is shown in the extreme position, drawn using the thin chain double dash line type. In assembly drawings, it might be the case that the engineer wants to show the fact that an adjacent part is present in the assembly. If that part itself is not very relevant for communication purpose, it can be drawn with the thin chain double dash line type. Every engineering drawing is made using the set of line types described earlier. Now, let us analyse the example. A wing flap mechanism front view. Thick continuous lines are used for the visible outlines and edges. The thin chain lines indicate the centres of circles and cylindrical objects. The larger arc represents a pitch circle, also drawn using the thin chain line type. Thin dashed lines are used to show hidden contours. A partial section is used to illustrate some of the assembly's internal features. It is delineated by lines drawn using the zigzag line type. The sectioned parts are hatched using thin continuous lines, the line type which is also used for the 55-degree dimension. One of the parts is shown in its other extreme position, the outline of which is drawn using thin chain double dashed lines.